are in time, so let's start with the attendance. All right. So, so in the last class, we were talking about the naming of the some amide. I told you. So let's look here. So if you look this guy, see, that's a little big. I want to make this one. All right. That's a C, and then you have a O there, CO double bond O. There you have a OH, and you have a this CS3 like that. Yeah, CS3. So this guy is called the acetic acid. Yes, that's a vinegar. Ever see that? Acetic acid. Now remove that H with mm, that's a acetic acid. So this guy is acetic acid, and we eat as a vinegar in our kitchen. Acetic acid. So what I do here is now I'm going to remove that H, and then I put NH2. So let's put it there. NH2 here. N. Now look here. There are two bond around oxygen. NH2. And there are three bond around nitrogen. Now I'm good. So this is called acetamide. From acetic acid, it changed to acetamide. This bond is called amide. COONH2. This is called amide. Everybody got that? Yes or no? Yes. So what I did here is I write this guy. C uh, C 1 2 3. Hydrogen CS3 COOH. Acetic acid, right? Everybody see that? Now what I do is this is the acetic acid, just H left acetic acid. But if I take out that with N, and N has how many bonds? 3, right? O2 and 3. 1, 2, 3. Now this guy is called, that's the acetic acid. Up to there was an acetic acid. Now I call that whole thing is a acetamide. Have you got that? Yes? That's your acetic acid. I converted to acetamide. Yes? Now, I already told you, so this guy is a benzoic acid. So this is a benzene. And then if you have something like this, you call COOH. This is a benzoic acid. Everybody see that? Now, if I get rid of this guy and put N1, 2, 3, NH2, now this is called benzamide. Yes? Benzoic acid to benzamide. CONS2 bond group is called amide. Now, benzamide. What else I have here? Now, let's name one compound here. So, I'm going to name this guy. The first guy is like this, C double bond O, and there is a H, and there is N. And with that N, I have one H, and I have C in CS2, CS3. CS2, CS3. You see that? Everything is just satisfied with the 4 bond here. So around carbon 4 bond, around nitrogen 3 bond, around carbon 4 bond, so like that. So how you should name this is N-ethyl formamide. How they call this formamide? Look here. So this is it's coming from the HCOOH. So this group. So this guy is coming from that is a formic acid. So this is called formamide. Formamide. Everybody see that? Because that is coming from the formic acid, right? Formamide. And then with this N, there is how many C here? 1, 2. Two group, 2 C are called ethyl. 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 So you should write formamide. Ethyl formamide. Ethyl formamide. And where is that ethyl group? It's attached with the N. So we call N-ethyl formamide. That's how they name it. Ever see that? So I don't put this in the exam, yeah? So if you don't want to study the naming of the amide or whatever, don't worry about that, yeah? So you need to name up to the the acid part, yeah? So for example, in the last class, I told you something like this. something like this, and I have this one. So what is the name of? So I ask up to here. So you could say 1, 2, 3, propa. Propa, 3 is propa, COOH is called noic, propanoic acid. So that's a propanoic acid. 1, 2. Number 2, you have the 1C, that's a methyl. 2-methyl propanoic acid. So in the exam, you will only get up to the acidic nomenclature, not other. Yeah. So these are I'm not putting in exam. Ever see that how I got those names though? So this guy is called since HCOS, HCOOS. This is a formic acid. Now that's a formic acid. And now if I get rid of these guys with the NH2, I call the formamide. That's a formamide. Now this is NH2. I can write like this. That's a formamide. Now I can get rid of this H with the C and C like that, and I would call N-ethyl formamide. You got that? Yes? N-ethyl formamide. So like that one. So now let's go to the next one. N-dimethyl benzamide. Now let's try another one. Let's try the benzamide first. So I'm going to write the benzamide part. So the benzene. So benzamide is coming from the benzoic acid. So this guy is a COOH. Look here. So this is benzene. This is acid. So we call that as a benzoic acid. Everybody see that? Now I'm going to make a benzamide by taking off this one. N. That's called the benzamide. Everybody see that? Yes, benzamide. Now I'm going to make the dimethyl benzamide. So I'm going to get rid of that H and that H with the CS3 this side, CS3 this side. And now look here. So this is a complete. Now that group is called benzamide. So benzamide. So I call that is a benzamide. Now I need to include this guy. So there is with the N, there are the 2 methyl, 1 and 1. So I call dimethyl benzamide. And where is the N? Where is the methyl group with the C? With the N. So I call one methyl is in N, another methyl is also in N. So I call NN dimethyl benzamide. That's how they name it. Everybody got that? Yes or no? Good. NN dimethyl benzamide. So they give a little bit different system of naming than what we have already studied, right? So with the N, so they write, one methyl is with a 1N, and another methyl is also with the N, so they write the NN. Yes? They could just write the nitrogen as 1, and maybe they could write another way, but they started to name that way, so everybody named that way. Yes? Got it? Good. All right. So NN dimethyl benzamide. So let's go and look next one. So we are done with that one. So the naming of the amide. So here we are talking about the properties of the acid. So I'm going to write the acetic acid. So 2 carbon. See. So here is a O, and we have a OH here, like that. And you can put a hydrogen here. So this is the acetic acid, or you can put any other if you like. So I'm going to put another acid the opposite way. So what I do is, so I write here C, and then O, H, like that, and then C, 2 C's, like that, and just two way here, and then that's O. Ever see that? So this is one molecule, this is another molecule, right? Yes? Same thing. I'm just putting one pen the head this side, another pen the head this side. Yes? Just like that. Now, if you look here, so if there is a OH, it's a large minus. If with the H, large plus. When you see the OH, H is always large plus and O is always large minus. Yes? And then if you look here with this one, large minus, large plus. Like that. And if you look the C and O, tiny plus, tiny minus with a CNO, yeah? Not as strong as OH. Now look here, tiny minus, tiny plus. Now look here, so this plus head attract this head, negative head. So this is a force, so we call that as a hydrogen bond, H bond, hydrogen bond. And if you look here, this is a plus head, this is a minus head between 2 molecules here. So a tiny that, and we call that is a H bond. How many H bond between the 2 molecules here? 2. So it's like the 2 people are attaching with each other by 2 hands. Yes? So if the Warren and me want to stand up here, we are not holding with one in one hand. We are just holding each other by 2 hands. So we are really holding each other. Therefore, this guy is a very high boiling point, or most of the time you might see this guy as a solid. Although this is organic compound, it should be liquid or gas, right? But this guy looks to be solid. Why? Because two hands, they are attaching each other by two hands, and which is a great force in hard to separate. Everybody got that? Alright, so like that. Two hydrogen bonds are formed between two molecules. Therefore, this guy has a higher boiling point, higher melting point. If it is a solid, it's a higher melting point. If it is a liquid, it will have a higher boiling point, like that. Now, if you look the alcohol, now if you want to compare this guy with the alcohol, I'm just drawing it here. So let's look the alcohol. So this alcohol is like that. OH, this is alcohol. You see that? OH is alcohol. COOH is acid, OH is alcohol. Now, if you want to draw another alcohol here, CH here, and then OH there. O H here, like that. Now, if you look here, so this guy is a big minus, this guy is a big plus. This guy is a big plus, this guy is a big minus. Now, if you look here, so only one S bond is possible between the alcohol molecule, like that. Ever see that? So therefore, the alcohol has a lower boiling point. Yes, acid has a higher boiling or melting point. Ever got that? So if he and me attach our hand with the one to one hand, we can be easily get separated. But if we attach with the two hands, people cannot separate us. Ever got that? Yes? So we'll be in exam, yeah? It's an important concept. All right. So now let's look here. Now one propanol and acetic acid, maybe they have the very similar weight. So I'm going to write both here and show you which one has a higher boiling point. So here is the, how many carbon there? 1, 2, 3, 3 carbon, right? 1, 2, 3, 3 carbon, and all other is a H there. So I'm even not writing this H is there. Now I have the another guy is acetic acid, 2 carbon and double bond and OH. You see that? So I told you this guy can form 2 bond with another, and this guy can form only 1 bond with another. So this guy can be boiled easily. This guy can be boiled at higher temperature. Everybody see that? Should be boiled at higher temperature. The boiling point of this guy is 118, but the one propanol boil is 97. Everybody got that? So why alcohol boil at low temperature and why acid boil at higher temperature? You need to say, oh, the acid molecule can form 2 hydrogen between 2 guys, 2 molecules, but alcohol can form only from 1 hydrogen between 2 molecules. Got it? All right. Now, so if you look another, let's look one ester here, CS3CO CS3, CS3COO CS3. So this slide is showing CS3 COOCS3. So CCOOCS3. So this is ester. You see that? That guy is called ester. So this is called ester because COOOH CS3. COOC. This one is called ester. If there was NH2, we would call MI. Yes. If there was a H here, I would call that acid. Yes. So that's a ester. That guy is ester, and another is a CS3 COOH. So this guy is acid. Look here. So this is a OC here, that makes it ester. There is a OH here, that therefore it is an acid. So if you look here, OH, big minus with the O, big plus with the O. You see that? But if you look here, there is no OH here. There is a tiny plus, tiny minus, tiny minus, tiny plus, not big force there with another molecule. Ever see that? So always with the big plus and big minus, you need to look here. NH, if there is a NH, big minus, big plus. If there is a OH, big minus, big plus. If there is a FH, big minus, big plus. Other guys don't have that big minus, big plus. Ever see that? So when there are the small minus, small plus, they can interact with each other. So everything is low, 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 low. Yeah? So when there is a big plus and big minus, everything is high, high, high. Yes? Make sense? All right. So look here. So this guy has a OH, big minus, big plus. Therefore, this can make with another guy bond very tightly, very hard to separate. But this guy, tiny minus, tiny plus, tiny plus, tiny minus. So this really cannot bond with another molecule very tight. Yes? Is it clear? All right. So again, I will not be putting the ester or amide in the exam, only up to alcohol and acid. Yeah? Alcohol and acid. So if you don't want to study these things for the exam, that's fine. Now, let's look about the amide. Now, I'm going to write the amide. So amide. So let's compare between the, what's that one? This guy, amide here. So this guy. So C, H here, there, that one, and I have N there, and I have CS3, and I have another CS3. So this guy, look here. So this guy, N is connected with how many carbon? 1, 2, 3, right? Everybody see that? So this kind of guy is called tertiary amide. If N is connected to 3 carbon, that's called a tertiary amide. Is there a H here? There is no H here. You see that? There is no H. So there is a very tiny minus here, tiny plus here, tiny plus here, maybe tiny plus, tiny minus here, like that. Yeah. So its boiling point and melting point will be very low. The boiling point is 153. But if you look this guy, now let's look another amide here. So what I am doing is I'm not doing anything. So I could just write that one and CC like this, and then N CS3 there. Sorry, no, not CS3. H there, H there. Look at N is connected to only one carbon, so this guy is called primary amide. Make sense? Yes or no? Yes? So a primary. Now look at, since there is a NH, I already told you, when you see the NH, OH, or FH, you need to be concerned. So this is a big minus. This is a big plus. So it can form hydrogen bond with another molecule. So that guy has a higher boiling and higher melting point. Everybody see that? So that NH, FH, OH is a very important, yeah? Look here, there is a no NH possible here. No NH possible here. So can form hydrogen bond, low boiling point. But this is a NHS, there is a big minus here, big plus here. So it can attract with another molecules, a strong intermolecular force and very high boiling point up to 30. Does that make sense? Yes? So primary has a hydrogen, secondary or tertiary don't have a hydrogen with N. Now look here. So this is a secondary amine. Let's try secondary amine here. So I can write this guy here, secondary. Look here. So N is connected with how many carbon? 1, 2, right? So this is called secondary. Yes? Now, if you write another one, that's a secondary. Now, if you write that one, that's a primary. So I'm going to write another one here. C, H, O, C, N, CS3, so H, H. So look here, N is connected with how many carbon? 1? Yes? Therefore, it is called primary amine. Primary amide. If they are looking the, or they are not looking the CONS2, they are looking the amine here. But we could study this in another chapter. So rather than this one, I will teach this one in another chapter, but let's do it here. So let's write the secondary amine. So N here, C here, C here. So H here. Look here, this is N is connected with how many? 2, right? Yes, look here. So that guy, N is connected with how many? So N is this way, is 1, up is 1. So 2, yes? So that's a secondary amine. So this is secondary amine. If you want to write another amine here, so let's write N, and then there is a H, and then there's C, there's a C. This is also secondary amine. Make sense? Everybody got that? So secondary. Now this is H, NH, big plus, big minus, big plus, big minus. So big plus and big minus attract with a strong force. So that normally from the hydrogen bond, and we have a more boiling point if it is a liquid. Ever see that? Now, what is that one? So that was a secondary amine. Now let's look the primary amine. So primary amine would be like this. So primary amine would be that guy is gone, um, that guy is gone, that guy is gone. So look here. So this is primary amine. Why primary amine? N is connected with only one carbon. Yes, N is connected with only one carbon. Yes, so this can have a big minus. This is a big plus. So big plus, big minus. Now look here. This is a big minus, big plus. So it can also form the hydrogen bond. Yes. So tertiary amine cannot form the hydrogen bond. Primary and secondary amine can form the hydrogen bond. So normally primary and secondary amine has everything high, high, high. Yes. NH bond is very crucial. Yes. NH, OS, and FS. All right. So like that. Now, interesting carboxylic acid. So, formic acid. What is formic acid? There is a only one C. So, in the formic acid is like this: C O uh, OH. So one carbon. So this is a formic acid, and around 4 bond. If you look there, that's a formic acid. So if ant bite you, ant send this acid into our skin, and we feel the itching. That's a formic acid. Everybody see that? Yes? All right, formic acid. Now, acetic acid. So, if you have two carbon in COOH group, then we call acetic acid. 1, 2, OOH. Now, 4 bond around carbon, 2 bond around oxygen. So, this is called acetic acid. So, this is a vinegar. It's a vinegar, and we put in a pickle. Yes? Dill pickle. Everybody know that? Dill pickle in kitchen? Yes? Dill pickle. So, we put that vinegar, the cucumber in the that guy, and then that makes sour in taste. Got it? All right. So hexanoic acid has the full order of the dirty socks in locker rooms. Yeah. So if the socks smell, so hexanoic acid will be 6 carbon. 1, 2, 3, 4, 5, 6. So 6 carbon there, and then you need to put the OH at the last. OH last. So hexanoic acid. So if the socks are smelling, there is too much hexanoic acid in the socks coming out from the body. Everybody see that? Yes? Like that. Good. So this kind of the compound, so if you are just doing too much exercise or walking too much and your foot are just burning a little bit, and you need to put your foot in the water to make them comfortable, it's because your body is producing too much this acid and burning your foot. Everybody see that? Looks like chemistry is important, right? All right, so let's go to the, look the next one. Now, there are a couple of medicinal compounds. These acid work by removing the outer older layer of the skin cell, revealing the healthier looking new cells underneath. So there is a glycolic acid. So let's write the glycolic acid and lactic acid. So glycolic acid. So how many carbon in the glycolic acid? You look here, glycolic acid. So this is a, it's not alpha. So number it's not, it's the one is not alpha. So whatever is connected with the number 1, that guy is called alpha. Make sense? So this guy is the alpha carbon. So in the alpha carbon there is OH. So let's look here. C. There are 2 C, and then this guy is that one. And in alpha carbon there is a OH. Everybody see that? So this is called a glycolic acid, and this work as a medicine. So sometimes if your foot is burning, so if you put this from outside, it heals the foot. Yeah. So my foot was really bad last summer, and I was putting some yogurt in my foot, and that was giving me relief. So that's the lactic acid in yogurt or milk. Yes. So if you wash your foot or painful part with milk or yogurt, you feel relief, because this guy work as a medicine. So this acid work by removing the outer older layer of the skin, which are hurting. Yes. So like that. So that's the glycolic acid, and the milk acid or the yogurt acid is the lactic acid, and so there is C, 3 C's there, and there is a OH, and there is a OH, and there is a O here, and in alpha carbon there is a OH. Everybody see that? So this is not alpha carbon. This is alpha carbon. Yes. In alpha carbon there is a OH. If there is a OH in alpha carbon, this tend to work as a medicine for our body. Yes. So there is a medicine. There is a yogurt in market, Danone yogurt. Everybody see that? The Danone brand. I don't know if you go to market and you buy it or not. Danone. So long time ago, so that Danone was sold as a medicine. That was not produced to to eat. So they used to produce tiny packet of the Danone in somewhere in Europe, and they used to sell that as a medicinal yogurt, expensive. Ever got that? So just like that. All right. So lactic acid. Now there are not much things I need to talk here. So there is a aspirin. So aspirin is a we use as a antipyretic like to reduce the fever. If your body is too hot, you take that one and the fever is reduced. Yeah. This one aspirin or ibuprofen and naproxen. These are the acid compound. Look here at the end there is a COS group. There is a COS group. There is a COS group. So either they use as an antipyretic to uh, release the fever, to reduce the body temperature, or work as a pain reliever. Everybody got that? So again, this is beyond organic chemistry. I'm not going to ask this kind of question in exam. Yeah. All right. So let's go here. And how do these aspirin block the pain? So what they say is that there in our body there is this acid arachidonic acid. So there is this acid, and if from this one, if this guy is formed, so we feel pain. So it causes pain. You see that? So there is this guy in our body, and if this guy converted to this guy, we feel pain. But if you put aspirin in our body, so aspirin works here and blocks this guy becoming this guy, so we don't feel pain. Ever see that? So don't worry about the molecular formula, molecular structure. It's beyond our thing. Does that make sense? So the pain reliever is actually working by not allowing forming the pain causing compound. Yes. So like that. All right. Now look here, there are some, they are giving some ester. So this is a ethyl butanoate. So that is obtained from the mango. So if you go to the market, the mango smells so good, right? So what is the compound that is smelling? They are saying that is ethyl butanoate. So I'm going to write the butanoate here. So CO butanoate means 4 carbon. 1, 2, 3, 4 butanoate. So this is butanoate and this side is ethyl. Everybody see that? So there is 2 carbon ethyl, and there are 4 carbon with that COO group. So we call butanoate. Butanoate. So if you go to the market and you smell so good mango smell, that's this compound, ethyl butanoate. Everybody got that? Good. And then if you are going to buy the peaches, right? So that's a pentyl butanoate. So pentyl butanoate. So that's a ethyl butanoate. That's from the mango, and then pentyl butanoate. Look here, 1, 2, 3, 4, 5. That's a pentyl. 1, 2, 3, 4. Pentyl butanoate. So 1, 2, 3, 4, 5. Pentyl. 1, 2, 3, 4, 5. Pentyl butanoate. Ever see that? So 1, 2, 3, 4, butanoate, 1, 2, 3, 4, 5, pentyl. Yes? Pentyl butanoate. So that is the smell of the peach look like that. So don't worry about these things. There's too many things they are writing. Melatonin. So the amide melatonin is thought to induce the sleep because its production is increased by the body during the evening. So this guy is called the melatonin. So look here. So this is a benzene ring. There is a heteroatom ring there, and there is a NH, and there is a CO. So it's a kind of the CON. So it's an amide. You see that amide? Yes. So this is a melatonin. So if you take the melatonin during sleep as a supplement, you can better sleep. Yeah. Or maybe you do exercise or you do something, and maybe melatonin is produced. Yeah. Happy molecule and induce the sleep. Ever see that? So it's all about the medicine and higher level thing. So we don't have to worry about here. So the ester benzocaine is the active ingredient in topical anesthetic. Topical anesthetic. So for example, you have so you go and buy the market as like if you have a rashes in the skin, so you buy and you put it here, you feel relief. So there is a benzocaine there. Yeah. So that this guy benzocaine. So there is a benzene. That's a COO. So this is a ester, and there is an NS2. So this is an ester group, and this help acetaminophen. So acetaminophen is a pain reliever also during the headache or fever. So this is the acetaminophen. So that also works in the medicine. And if you look here, this is a CO here and H here. So this is the amide group. You see that? CO and H is the amide group. So those guys are working as a medicine. So they make millions of dollars by selling this compound, right? Yes. So everywhere you go, these are the pain reliever is Tylenol for babies, Tylenol for adults, Tylenol for uh, old people. All they come in the different brand name, but they are the same thing. You got that? So this guy. Now, so this is important. So this is organic chemistry. We need to study this one, yeah. So this is important. So you need to study for this for your exam. Now, the acidity of the carboxylic acid. Why acids are the carboxylic acid are acidic? So if you put the acid, let's write this one. COS. So if you put this guy in S water, so put in water. So you put in water. So this H is going to go and attach with this one. CO and then CO there, and then since H is gone, that becomes minus, and H is gone, there is a plus, then that becomes H2O is already there, then H3O, it becomes like that. So this guy is acidic, sour in taste, SOUR, sour in taste, TASTE, taste. So this is sour in taste. Therefore, this is the guy that gives the sour taste in pickle. Everybody see that? So this is the acetic acid, so formic acid. So I could write the acetic acid by making two carbon here. So this is the acetic acid. You see that? That's a vinegar. So no matter which acid you pick, H is always going to go and attach with that one, and this becomes minus, doesn't do anything. Then S2O picking this H plus becomes S3O plus, and this is the acid. That S3O plus is the sour in taste. That guy. Everybody got that? So this guy is a acidic. So if you put 100 molecule of this guy in water, 100 molecule in the water, maybe one molecule break, other don't break. Very, very low ionization of this guy. You see that? So if you put the acetic acid in water, out of 100, maybe one molecule break is this one, like this, but other 99 don't break. You got that? It's just like if there are 100 students, one pass, 99 don't pass. Like this, yeah? And still if you taste the pickle, they are still so strong as sour in taste, right? Very wicked. Like this. So these are weak acid. So organic acid, the acid from the mangoes and the lemon, they all are weak acid, so we can eat, yeah? But hydrochloric acid, sulfuric acid that we use in a lab, we cannot eat them. That's too strong. Yes? All right. Now, so same thing here. So what we are doing here is we are doing the reaction. In this slide, we are doing the reaction not with the water. So we are doing the reaction with the NaOH. So this is the acid you have already there. So this is the acid. Now you mix that with the NaOH solution. This is a base. So this guy is an acid, and this guy is a base. So these two guys are combined, OH and H. So that gives you H2O. Have you see that? H and OH combined to give H2O. Yes? And what I'm left with, so you just copy that, CO, then CO, and then you have a O. You see that? I already take this H out, right? So that H is gone, so there is a Na. OH and H already give water, so Na comes and sit here with this like that. So this is a salt. This tiny minus, tiny, I mean actually it's a big minus and big plus. So this is a salt, and then this is acid, water, salt and water. So this is a neutralization reaction. This was acid, this was base, and this is salt. When acid and base combine and give salt and water, we call that as a neither acid, not base. It's a neutral salt and water. Ever see that? Yes? Good, like this. So just study this thing a little bit. So this is important, yeah? Make note, yeah? This slide will be in exam. Acid base, we need to understand this simple concept. Now, if you look here, same thing. So I'm not doing anything. So look here. So the COOS. So this is the acid group here. You don't have to worry about it. You can write anything you like here. Yes? If C, how many C you want to put, that's fine. Yes? So when you look here, COS and OS. So that S and OS combine and give water H2O, and that Na go and sit with the O, and that's ONA. I'm just looking this part and water. Does that make sense? You don't have to worry about about these things. What is there? Maybe you can write anything you like. Yeah? CS2, CS2, CS2. How many CS2 you want to put? Good? Yes? Only that the head I am looking. So the head of this guy is this one OH and NaOH, H and OH combined with the water, and the Na2 and sit with that there. So that's important. That's called the sodium acetate. What this guy is called. So if you put here, so this is the acetic acid. It's coming from the 1,2 carbon and COA. That's acetic acid. And if you put the sodium here, this is called sodium acetate. And if you put the potassium here, you would call the potassium acetate. Yes? So again, these things will not be in exam. Sodium acetate, potassium acetate, I don't put, yeah? So, but you need to know the neutralization reaction, yeah? That OH and NaOH combining to give the COO, Na and water. Good? Now, how does the soap clean the dirty clothes? So look here, soap looks like this. The soap, I'm going to write the soap here. Soap, let's write the soap. How much time I have here? That's 10, 6. Soap. Now, this guy is a soap. So COONA. So this salt is a soap. So what are these one? Carbon. You can just write how many carbon you want. Yeah, doesn't matter. So if you look there, that's a long chain carbon molecule. At the head, you have the COONA, and that's a soap. Soap or detergent, whatever you use to wash your clothes, hair, everything. Ever see that? So this is a soap. So there is a minus, there is a plus. So this is called polar head. Polar head. Polar means what? Plus and minus, right? And there are no plus and no minus. No plus, no minus this side. So this is called non-polar. Non-polar tail. Ever got that? Yes or no? So, yeah? Doesn't matter. You see that? I just write whatever I like. Yes? So put as many as you want. Yes? Yes or no? Yeah, so like that. So, like this one. So this is a soap. So this is a non-polar tail. All carbon are non-polar tail, and the CO and ONA. There is a Na. They are not showing here. So they actually O minus they are writing. You could write a Na here. Yeah. Got it? So this is a soap. How does it work? So it works like this. So when you put so this is the soap. And how does this soap work? So let's look here. Now, how does this soap work? So I'm going to make a structure of the soap micelle. They call micelle. M-I-C-E-L-L-E, micelle, soap micelle. When you put the soap in water, it forms like this. So what happens is that this is a carbon and there is a COONA. And then this is another carbon and then this is COONA. And this is another from another molecule COONA. This is another COONA like that. And then there is a COONA. You can write the Na there. So pumps like this, and then you can just see. Ever see that? So it pumps the micelle like that. All this tail come toward the end, and the all OCO and the polar head comes toward the out. So it's a pumps small ball spherical structure like the tennis ball. Ever see that? And toward the inner side, all carbon chain, and outer side they have the COONA. Ever got that? In the water. So in soap looks like this in water. Water. Good? So what when you put this one, and if there is a dirt in the cloth, so the big dirt this is in the cloth, which is also non-polar. So these guys try to dissolve this guy. Cut, 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 cut. This non-polar tail cut this one, and then when they are cut from the cloth, the dirt, and then this micelle just capture that dirt, and the water washes away soap and that dirt together. Everybody? Yes or no? Yes, you got that? So basically that soap micelle inner side, that long tail are cutting the dirt from the cloth and taking out. It's just like the scissor cut the dirt, right? So sometimes if you something is bad in your cloth, you might cut that with the scissor, right? Basically here the soap inner side of that, the long chain carbon of the soap molecule working as a scissor to cut the dot. Remember that? Dot is non-polar, and non-polar dissolve non-polar. Dot is also non-polar, those long chain also non-polar. So non-polar and non-polar cut each other. Yes? And when the uh, uh, when the dot is caught by the this tail, and the water just wash away everything, and clothes become clean. You got it? Like that. All right. Good. Like that. So grease. They are writing the grease for the dot. Yeah, that dot is a grease. Grease is a non-polar. Everybody see that? So the dot in the cloth is called what? Grease. Yes. So for example, if you use grease in home, so your hand become very sticky, dirty, right? And you need to use the soap to wash them out. Yes. Everybody got that? So grease. They caught that grease and uh, put inside, and water can wash everything away. Good. All right. Now this is very important. Yeah. So let's look some reaction. So these reactions are important than other thing. Yeah. So we need to understand this reaction a little bit. So let's look here. So I have the RCOOL. So what is R? C. You can put as many as C you want there. Yes. I'm definitely putting these questions in exam, yeah? Just make a note. So RCOS. Now I am reacting this with the alcohol, OHR. What is this R here? Again C. You can write C, C, and OH. It's like that. You see this R is this C and this OH. You got that? Yes or no? So this R is nothing other than CC. Doesn't matter how many C you want to put. Yes? Good. Now I just write the R here. Now you need to do this reaction. You need to put a little bit sulfuric acid there. Just to put a mix this guy and this guy, and put a little bit sulfuric acid, and you will get the nice smell like the fruity smell we call ester. So what happened? These two guys go away. So this guy and this guy form water, and they go away. OR and HOS. So look here. So this one, anything you want to, just these two guys are gone, and then you are just bringing these two molecules together, RCO and OR. I'm just interested, I'm not interested in the OH and H giving water, so I'm interested with that molecule. You got that? So that is ester, COO, ester. So it smells like the fruit. So if you take a little bit alcohol and a little bit acid and throw it together in a test tube and put a little bit sulfuric acid, it gives a fruity smell. Ester. So this reaction is called esterification. Look here, esterification. So basically we are just getting rid of one OH and H as a H2O, and I am just bringing this part and putting it there. Got that? So we'll be in exam, yeah? This is called esterification. Yes? When is the exam? The exam will be the first week of the December, the Wednesday. In the last week of the December, we will have quiz 3 after the Thanksgiving break, right? And then we will have the exam, and we go home, and we come back on the final. We are done forever. Free people, yes? All right. Good. Like this. Good. Now let's look here. They are giving the example here. So that's the they were putting the R there instead of R. They are putting that's alcohol. So CC 2C that side, and you have COOH. You see that I'm not putting H there. Yes. Everybody that? Yes. See. So I'm just not writing H there. Now another side they are writing the 1C O like that. OH like that. So this is alcohol. So this is like that. Like that. Now what should you do? You just get rid of these two guys and then bring it here and connect it. You got it? I didn't do anything. I just copied everything. I just cut this one like how I would cut the Lego, and I bring that and connect there. Yes? Who didn't understand this? Every got that? Exam question. Just make a note, yeah? It will be an exam. Write the esterification of reaction, or I give two molecule and write the product, what will you form there, like this, yes? I don't have to worry about anything. So what I did here is just get rid of that guy, take this guy and connect out. Organic chemistry is all about cutting and connecting, you see? So we don't have to understand. There are not many principles there, yeah? But in the foundation or other course, we see too many principles, yeah? Everybody that? This one? Very simple. Very simple, very important, yeah? Esterification reaction, we need to understand. Here, same thing. Look here. So this guy is a OH. This guy, you are just, this guy and this guy are getting rid of, and you are bringing it and attaching it here. So like this. Got that? Yes or no? Simple, right? So now if you look here, this is a amine. So this guy is amine because there is a N, there is a OH. So you do the same thing. So H and OH are gone, and you are bringing it and attaching it here like that. Same thing. Yes or no? Same thing. So, but probably I will not put this amide, but esterification, the previous one definitely in exam. Yes? You got that? So like this. Good. Now let's go here. And same thing here. So that is H and OH are gone. And you get that NH2 here attached. Yes? Easy. Ammonia. Now here, look here, this one H, you can put any H, yeah? So this H and this OH are gone. And then it has that guy, this guy here with N. You got that? Every time. Yes? Good. And if you look here, this is H, this OH. So H and OH are gone as water. So it has this guy here. And you got that one. Yeah? So they're writing NCS3 too, but you don't have to like that way. So you can write CS3 like that, CS3 like that. Yes? Have you got that a little bit? Simple, yeah? So you are just removing these two in, and you are attaching whatever is left there, yes? All right, so you can just read that one. Now hydrolysis of ester, that's now opposite. So this is ester. So I'm going to write this here. Hydrolysis. Hydrolysis means you are breaking. Lysis means breaking, right? So we are breaking there. So let's write the ester. So COOR. There you can put R. What is R here? It's not C. How many C you want to put? Yeah? This is R. How many C you want to put here? Doesn't matter. Make sense? Everybody? Now I'm going to put water. HOH. So what happened? So OH, look here. So the OH replaces OR. So from water, that OH is going to replace OR. So you just clip it here. Lysis means break it here. And this guy go and attach here. So like that. So if you do that, add CO and then OH. This go and attach there. The OR is gone with the H. So that becomes OR H. So this H is go with the O, this OH go and attach with that. Ever see that? That's called a hydrolysis. Again, hydrolysis probably I don't put in exam. The esterification, the first, yeah? How to come ester from the acid and alcohol, that's important. Good? Because we do those kind of reaction in the lab. We don't do hydrolysis of ester in the lab. We make the ester in the lab, yeah? So if you do lab in the future, you probably doing the making the ester, not breaking the ester. Yes. So I put the exam according to the order of the importance what we do in our life. So here, if you look here again, if you put a little bit of the OH there, any OH there, you could write like this one. So I just show you here what they are doing. So let's write that benzo is that I don't know, acetate, some benzoate, I don't know, the benzoate, acetate, I don't know whatever is that. COOCS3, right? So this is a ester. You see that? COO, that bond is a ester bond. Now, if you are boiling it with HOH or water and you are putting NaOH. In previous, I was saying that, oh, get rid of this guy and then put it with the H and take OH and put it here. That's what I told you, yes? So let's write that one first. That one, and then CO, and then OH. I told you this, right? Yes? But this is acid, but you have the base there, so what that base does is, this takes away that H and comes here and sit as a sodium. You see that? First it becomes the acid, and then that acid reacts with the NaOH base and gives the salt. Yes? You got that? Previously, what I told you in the previous reaction, I didn't put NaOH there. So in that case, when there was no NaOH, I would write like this. You would write like COOH. That OH go and sit there. See that? That OH go and sit here, and then that HN, that OCS3 go as alcohol, like that. In previous, I told you this, right? But I'm also putting NaOH. So if I'm putting NaOH, so this H group is taken away by OH and Na comes there. That's what I'm saying. Yes? You got it? Who didn't understand? Simple, yeah? So you got something, it has something. That's it. Here, so organic chemistry, I taught multiple courses here, and student found organic chemistry is the most easiest subject. So all, I think this is my third semester here, and nobody has a problem with organic chemistry so far. Yeah. So it's just cutting, pasting, no principle, no math, nothing. I mean, there is always a couple of students are like struggle, but in general, it was always good. Yeah. So same thing. What they are doing here is in the first one. Um, in the first one, they're taking the amide and they are just getting reacted with the water, and that's NHCS3 is gone and OH is attached. You see that? So it's simple here. So this is water, and they put a little bit HCl for the reaction. So this is water, H2O, and there is a amide one, CON, H here, CSP here, and this all is gone. This OH going attached here, CSP, CS2, CO, OH here, and this is gone here. CS3 NS already there, CS3 that become NS2. Yes? CS3. Look at CS3 NS, right? CS3 NS is already there, right? Now this H go there and that becomes CS3 NS2. CS3, that's NS2 or NS3. Maybe get one H from here. CS3 NH, and there is other TH. Maybe one comes from there. Yeah? So NH, so this goes there, NS2, and maybe that goes there, NS3, and that becomes plus, and this here comes here to balance this start. This is plus, this is minus. Yes? Everybody got that? Yeah. But no exam, yeah? That not exam. So maybe in next year. So we study the same thing. You go to the PhD, you go to the whatever you want to do higher level. These are the same reaction always. But you just want to focus in certain part, yeah? A certain thing, maybe you want to study that in detail, how it happened, but it's simple, yeah? All right, so now that's a NS2 again. Look here, that's a NS2 here, that's a NS2 here, that's a water with the NaOH. So if OH go and it has here, that's look at that's OH, and I just want to do that one. So let's do this one. Benzene ring here, then you have amide bond there, CONS2 amide bond here, and then you are doing that reaction with HOH. Now if you do that, so what happens is OH go and attach here. So that's like this, COOH. You got that? Yes? COOH, right? The NS2 is gone. So this NS2 is gone. So COOH I write here, yes? You see, OS. I did write ON. Yes? But I'm mixing that with NaOH. So also I have NaOH in the vessel, reaction vessel, and that OH is gone as a Na. So that's minus, that's plus. You see that? There was a base. If there was no NaOH, you just got COOH here. No OH. But since you are putting NaOH also, the H is gone that way, and OH that comes out. Yeah? So we should not be interested about this guy. We should be be interested about this guy. Yeah. So one is a major product, another is a minor product. So we just use a major product. Yeah. Everybody got that? All right. So what I have here. Oh, this is a polymer. How much time I have? 25. Discard. So, oh, we are almost done. So let's go here and look here. So this is a polymer. So polymer. If you look here, uh, this is the one part. So if you look here, so wool and silk polymers with many amide bonds. So amide are basically the kind of the protein. Look here. So this is the amide bond here, CONS. And here, if you see CONS, there is a CONS. So this is one part of that polymer. So it's connected in many unit together, and it's a long fiber. Here, you see that? It's like the hair. Everybody that? So wool and synthetic polymer, polyamide, and polyester. So this is a polyamide. Why polyamide? CO and S is an amide group. Yes. So there are many amides. So this is amide, this is amide, this is amide. So there are many amides here. So we call this is a polyamide. Yes, polyamide. Now let's go and do the next one. Again, all organic chemistry should be valid here. 4 bond around oxygen, 3 bond around nitrogen, 2 bond around oxygen, 4 bond around hydrogen. Yes, sorry, carbon. Everybody see that? So like this. Now let's look at polyester. Now look here. This is a nylon. So is that a ester bond? No, it's a amide bond. Again, amide bond. Look here. So this one is a acid. You see that acid? OH is an acid, right? OH is an acid. NS2 is an amine. And if you boil this one and this one together, the OH and one H and one O is gone, and then that becomes NHCO. Look here. So OH and H is gone. This guy and this guy gone. You see that? This one and this one are gone, and N is one H is with this one, and it connect here. So this one and one H is gone from here is a one. You got that? And then they connect there, and this process continue, and then you form the long chain. Yes. So this is also polyamide. Why polyamide? NHCO, amide bond, CONS amide bond, CONS amide bond. So we call it polyamide. Many amide are there. Yes. You got it? So don't worry about this kind of thing in the exam. Yeah. So I'm not giving override the reaction between this polymer, this and down. Yeah. So we don't do that kind of thing here. Now look here. So this is a ester. This is a polyester. Why is a polyester? Now if you look here, this is a CO group. Look at COOC. This group is a ester group. Yes. Ever see that? Ester. COO. This is ester, and this is also ester. This is also ester. This is also ester. This is also ester. So many ester there in that chain. So we call polyester. Everybody that? So previous polyamide. This is polyester. And if you see many double bond in the compound, the chain we call the polyethylene. Poly. So if you remember the previous, so polyethylene would be like this. So CS2, CS2. So this is ethyl group, and there's another ethyl group, just keep joining, and then you get a polyethylene. This is a polyethylene. Plastic every day we use it, Walmart or other store, right? Polyethylene. Yes. And then this is a polyester. This is a polyester. Why polyester? Because this is ester, this is ester, this is ester, many ester, and that's a polyester. Ever see that? So you need to identify what does a polyester mean? What does a polyamide mean? What does a polyethylene mean? Yeah? You just need to know the name, but you don't need to know the reaction writing like this for the exam. Yeah? Good. All right. There are some synthetic polymer. Now let's look here. This is a penicillin. This compound is a very famous guy. Penicillin. This guy compound is if your body is not tolerating the organism, biotics, we need to give the antibiotic. Yes? So this is I think long time ago, I don't know, Alexander Fleming. Yes, this is a very famous guy. He isolated this compound from the fungus. You see the like the tiny, tiny white germs coming and spreading that, right? So they are fungi. Have you take the biology and fungus? Yeah. So the fungus, you can get these guys from the fungus, and those fungus can kill the bacteria. So if you give this as an injection and you take orally, so they can just kill the most of the bad organism in the body. Yes, antibiotic. So this work as a antibiotic. Then what is this antibiotic? Look here, this bond here, CONS. So this bond is a amide bond. And if you look here, NCO. So this bond is also amide bond. So in this guy, there are two amide bond there. You see that? And this is a CC here. So they illustrated this structure. So people knew from long, long time ago. So if you put certain kind of the soil in your own, that heal the own. But why they didn't know. But later on they realized that oh, there is a fungus, and that fungus produces some chemical like this, and that chemical can kill the bacteria, bad bacteria. Yes? Antibiotic. Everybody that? So fungus can kill the bacteria, and we don't sell fungus, we sell the that extract of the fungus. You got that? So so again, they are not for the exam, yeah? So these are beyond organic chemistry. Now let's look here. Focus on health and medicine. Penicillin and amoxicillin. So this guy is amoxicillin. You see that? So if you have the lung problem, in a lung infection of anything, so they give this compound. So this is the penicillin Z. So if you look here, the penicillin, it's another kind of the penicillin, so CON, so amide bond here, CON, another amide bond here, and they are replacing the original penicillin by some benzene ring there. So always this drug company always do something. So they take the original compound and they just try to replace the original group by something, and then they test whether it works or not, or better works or less works. You see that? So originally, long, long time ago, uh, Alexander Fleming took this made this compound from the fungi. R was here. Maybe there was a C. You see that? Maybe there was a C. But later on, the company produced the amoxicillin just by removing that R with the that carbon with the benzene ring. You see that? Benzene and CS2. They put it there and they sell in the market and make multi-billion dollars. So when they do something like this, they can get a patent and sell as a branding. You see that? Like this. And then this one, look here, in that benzene, they put, there was a that in the penicillin Z, in another compound, they take the benzene ring and they inserted a weight in that benzene ring. And did a little bit difference here. CS2 there, they put the NS2 group here, and they make this compound and they sell as amoxicillin. So, but this guy, I think all guy work the similar way. Maybe a little one's a little better, a little bit less, but whatever penicillin can do, this amoxicillin can be the same or similar. Yeah, got it? Yes. Yeah. So in future, if you work in the drug company, drug industry, you might be working around these guys, and maybe you go to the market and you go, oh, what happened if I move this CS3 with some oil here? Can I replace this oil? And you try to replace this oil and then put in the mouse, and does it work better than amoxicillin or not? Yeah. But I don't think you can completely get a new away from this one. This is always there. You see that? So what they do, oh, there is a S. Can I remove this S with the O, and would that work? And you try, yes? So originally, this is the compound, and everybody works around this compound. Everybody that? Like, all right. So we are done with this chapter, yeah? So I have only one chapter, but that will not be an exam and no homework for that chapter. I mean. So whatever I already put the homework, if I have not put this chapter in homework, I will put this